this going. We have 5 people. We're going to play a game. I just want to play with one other person, though. All right, so Ben, you're in my group. The other 3 kids are going to be like, well, screw you. We're going to play, we'll make our own game. And so they run off and they play by themselves. So now, while you have your game going with 2 individuals, they have their game going with 3 individuals. All right, so groups are naturally created. Right? So, what does that mean? Well, right now it seems like a fun fact, but kind of down the line it means that you can use information that may not otherwise seem to be useful. So, for example, if a question were to ask me, just think in terms of questions, you know, what is the number of ways you could break a group of 10 people into, I don't know, 7-person groups, but then somewhere else it was given that 10C3 was equal to, oh, I don't even know, hold on, 10 times 20 divided by 2. Hold on, I can figure this out. Don't tell me. I mean, you weren't going through it, but I just like to do some mental math, and it's early enough on a Saturday morning that I'll be proud if I figure it out. So, $120? All right. Phew. Right. Yeah, so just so, in case you're kind of a math nerd like I am, and that doesn't mean that you like all things that you learn in math class, you just like numbers and how they interact. So I figured out 10C3 instead of figuring out 10C7, because that would have been a pain, right? So what that is the same as 10P3 over 3 factorial. So this is the value in knowing some of the rules. 10P3, and this is a good review, is telling us that I have 3 slots available and 10 people to fill those slots. Any of the 10 people can occupy the first position. Once a person's placed, any of the remaining 9 could occupy the second. Any of the remaining 8 could occupy the third. All right. Then after that, on the bottom, I have 3 times 2 times 1 for the 3 factorial. So what I did was I said, all right, well, I know this is going to simplify, this is going to simplify. So instead of actually multiplying 10 times 9 times 8 and dividing it by 6, I was saying, and that's what I was staring at. I knew I wanted to hang on to a 10 because that's an easy number to work with. I knew I had to take the 9, I had a 9 and an 8 and a 3 and a 2. So 9 with the 8 gave me a 3, the 8 with the 2 gave me a 4, 3 times 4 gave me the 12, and that was easy to multiply by 10 later on. And so that gives me the 120. All right, so knowing this complementary relationship is really useful for those kind of calculations, but sometimes it could even just give you the answer. I'll throw a question like that on the test. I hadn't had it on there previously, but since I'm talking about it, I might as well. Not one where you have to do it by hand, but one where you could use this relationship. You know, kind of hide in there the fact that, I don't know, like 20C1 is equal to 20, and then ask you to find 20C19. Yeah, where you can just use that information. So I didn't want to figure out 10C7. That would have been tough, but this is much easier. Not to say easy, but easier than the other one. Okay? Not as easy as the calculator, but it's kind of fun. It's a good way to stretch your mind a little bit. Well, actually, that's not even stretching. That's the workout. Yeah, that's the weightlifting.
I'm gonna get that question wrong because I don't know what you're talking about.
Oh, that's a wonderful way of saying that. Yeah. I mean, when you went down your list of all the different ways of asking after saying that, that's what you felt about that.
When you said I was going to the test, I was like,
Yeah,
Okay.
because all I'm talking about, once I have out of 5 people, if I have a group of 2, it's just what is remaining. Because it's kind of like, I only care about 2 people. So how many people do I not care about?
Okay.
You know, so I'm an elementary school teacher who's ineffective. I'm looking at my class, and for some reason I'm only focused on 2 of the kids. How many kids are about to go kill themselves accidentally? Right? That's what's happening here. All right, these are the outcasts.
Okay.
And so the total number of possible ways I can group the outcasts would be the same as the number of ways I can group the people I actually care about. Okay.
And then.
Oh, sorry.
Sorry. And then how did you see that whole? What is the standard there?
That's just a side example. Yeah, it's greater than $1 plus.
What is the 120 called?
That, if you were to put this in your calculator, that's what you would get. Yeah. Yeah, any of this stuff you can go with the calculator, yeah. On the test too, yeah. All right, so again, the generalization, just like the last 2 concepts, we could generalize by using a formula. And this is the formula I had to learn when I was a student. That's fun. It's kind of hard to really understand why things are working the way they are with this one. This is the one that I settled on when I had to do it by hand and the calculator didn't really exist in my world yet. But now the calculator does exist, so we're in good shape. All right. So by hand, something like A would amount to, we have 2 spots. Any of the 4 people could fill the spots. So any of the 4 people could occupy the first position. Once a person's situated, then any of the remaining 3 people could occupy the second position. All right. You could do that with a tree diagram also. I mean, it's kind of overkill, but oh, 4 minus 1 to get, you're minusing 1 every step of the way. Yeah. As compared to 4C2, so somewhat different, 4P2, 4C2, so same parameters, 4 and 2, but now I have the C. And yeah, it's going to be 6 because what we're going to do is take our whatever we get for 4P2 and divide it by 2 factorial. And so from part A, we knew that 4P2 is equal to 12. 2 factorial is the same as 2 times 1, which is 2. So we get a 6. Let me turn the sound off on this. All right. 5C0, that's one of the weird ones. It's kind of hard to even visualize what a tree diagram would look like for that. Where you'd say, all right, I have 5 people. How many ways can I create a group of no one? We assume that there's one way that you could do that. There's one way in which you can choose to not create a group. I think it would be a little weird to say, all right, class, I'm going to create X number of groups. I have 20 of you in here. I'm going to put people into groups, but those groups are going to contain 0 people. All right. So group A will contain 0 people. Group B will contain 0 people. Group C, and so on. They'll be like, well, you didn't have to read out the entire list. We understood what you're saying after the first group. Like, okay, none of the groups are going to have any people in it. Great, that's fine. By formula, you could also get it, but that's kind of involving the same amount of reasoning. The calculator is where you're going to go on. That's not the calculator. Calculator is where you're going to go on this one if you're in a jam, because, and I'm going to actually prove this relationship or some aspects of this relationship to you in a second, because one of the foundations of this idea is the fact that 0 factorial is equal to 1. And that's just a strange thing to think about because it's like, well, factorials involve multiplication. And I've always learned that if you multiply involving a 0, the answer is always going to be 0. So how on earth could it be equal to 1? All right, so we'll have to address that in a minute. But in this case, it's 5C0, so let me put the 5 in. Math, probability, option 3, then pop in the 0, and you get a result of 1. All right, so calculator by hand, either way. All right, so you just want to try to develop an underlying understanding of this stuff because it makes it that much easier to diagnose problems. 6 factorial over 3 factorial. That's one of the problems that I look at. You may disagree, but I think it takes more time to put it in the calculator than it does to actually do it by hand. Because 6 factorial is 6 times 4, 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. If you divide two numbers that are the same, they divide to equal 1. So all of these numbers would cancel out. So all I would have to do is multiply these 3 numbers. All right. So, I mean, you then have to do that correctly, but, you know. But it's pretty doable using a by hand approach. That's the kind of thing, like factorials, most people, they can handle factorials by hand conceptually, or even writing it out. It's the permutations and combinations where people get jammed up, right? Because if you know you're multiplying by consecutive values all the way down to 1 with factorials, you're usually in pretty good shape. 14p14. Now, along the same lines as really A and D, that's telling us that I have 14 blanks. And 14 people. So I have to multiply until I fill up all the blanks. And, oh, that's going the wrong way. So I filled all the blanks in, and now I have this monstrosity. What's that equivalent to?
0.
Not 0. If it went to 0, it would be. If I multiplied all these numbers, I would get some monstrosity in the calculator. But this is equivalent to some other expression. What do you get? What kind of expression allows you to start with a number, end with 1, multiplying all consecutive values in the middle? 14 exclamation point. These two things are the same. And if you put this into your calculator, you type in 14p14 or 14 factorial. Either way, you get that. That's not going to work for us, right? Because of the rounding issue. You'd have to write out this entire decimal, but even still, it's the calculator is rounded off all the values after the 2. So this is it's not even a good estimator of what the correct answer is. So what we would actually do is leave our answer in factorial form. All right. You can leave your answer in factorial form if by applying the factorial it gives you something in scientific notation. All right. So that's the general rule of thumb. If by putting it in your calculator it gives you scientific notation, then you leave it in factorial form. We don't want to leave it in permutation form because you haven't really answered it yet. All that being said, what's going to end up happening is that this will be part of a larger problem, and in that larger problem, you'll probably have to use this number in another calculation, and things will start to clean up after that. So it won't be as daunting as it might seem. All right. Now, part F is asking us to take 14 people and put them in groups of 14. There's only one way that that's going to happen. Because if I'm taking, I'll go with a smaller example. If I have 3 people and I want to put them in groups of 3, try to conceptualize that. The only way that you could try to put them in different groups of 3 would be if you were to start rearranging the individuals. But rearrangement is a hallmark of permutations, which is a different concept. This is a combination. So anytime the only way that you would get a different grouping would be to rearrange, it would not be a combination. All right. So these kind of, I'd say they support the shortcut rules. They expose us to the shortcut rules, but these are some things that, they're nice if you see them, but again, the calculator does a lot of this for you. So the one I think that's probably most important here would be the NPN is equal to n factorial, because that's the one that tells you to kind of write something different on your test paper than maybe what the calculator would tell you. All right. The other ones, they come out the same way the calculator comes out. 0 factorial equals 1. I addressed that, but we're going to talk about it a little bit more in a sec. NC0 is equal to 1. That's the same as part C. NCN, that's the same as part F. NCN minus 1. That's just a cool one. It's a cool relationship. Oh, that's weird. I don't have an example for that one there. Oh, that's funny. All right. I'll take it as a typo for part G, I guess. So we would say, for example, I'll move this up a little bit. 20C19. That's going to result in a 20. If we had to do it by hand, it would actually be pretty crunchy, but it's actually not that bad, but it's got some teeth to it. All right, so if there's only a difference of 1 between your starting value and your ending value for a combination, then the result is the starting value. Okay, so that's a pretty cool relationship. Again, something the calculator will give you, but it's nice to know. Only a difference of 1 between the starting value and the ending value. Identify which one? Oh, okay, yeah, sure. I'll write them next to them. So we have, 0 factorial we're going to do over here, so that's, put that there. NPN, that was E. C for NCO, F for NCN, NCN minus 1 I just addressed. And the NCA one, that's what we were talking about on the top, so top of page. My arrow looks terrible. Oh, geez, I cannot write. I wanted to write 1 with a question mark. All right, so a little proof here. Kind of cool. The question is, how is 0 factorial equal to 1? Because that looks like it shouldn't make any sense whatsoever. So, let's investigate. We have a rule, and we talked about this last class when we talked about factorials. N factorial is equal to n times n minus 1 factorial. Right. And this is a pretty clever proof. I only say that when it's something that I did not come up with, because I can appreciate that. I for one, didn't. I just took it on faith that it was a true statement. I believed it, and I hoped that it was true. Otherwise, my knowledge and probability would fall apart. If I put in a 0 for n, that doesn't really help me, because that's what I'm looking for, and it would zero out the entire right-hand side and just really support my misconception. So what I'm going to do is I'm going to replace the n with a 1. So let n equal 1. If that's the case, we get n becomes 1 factorial is equal to 1 times 1 minus 1 factorial. We'll clean that up in a second, but all I'm doing is replacing each of those n values in the rule. This is a rule from, I think it's 2 pages ago. All right, factorial rule. We let n equal 1. And so I know, whether it's calculator or just by using common sense, that 1 factorial is equal to 1. I also know from, I guess, I don't know, graduating kindergarten, that 1 minus 1 is equal to 0. I don't think that was a snotty comment. I think that's, I mean, if you don't know 1 minus 1 is 0, we gotta talk. Like, and so 1 times 0 factorial would be 0 factorial, and the left-hand side ends up being equal to 1. So we get, as a result, 1 equals 0 factorial. And so this would be our proof of that relationship. Right. But as long as we can get through the rule a relationship between 0 factorial equals 1, then we've done our job. So this was page 32.